Today's lesson is on exponents and roots. Before we discuss exponents and roots, we are going to review what inverse operations are. Inverse operations are two operations that undo or cancel each other out. Two operations that undo each other. Ones that you probably are familiar with, addition and subtraction. Those are inverse operations. Multiplication and division. Are another example of inverse operations. Because inverse operations undo each other, because they cancel each other out, they come in sets. So if we think about 5 plus 2, 5 plus 2 is 7. We can write this same number sentence using subtraction. 7 minus 2 gets me back to where I started at 5, right? 5 plus 2 is 7. 7 minus 2 is 5. We can do the same thing with multiplication. 5 times 2 is 10. It's a times sign. That means the same thing as 10 divided by 2 is 5. One is written with multiplication, the other one is written with division. So inverse operations are two operations that undo each other. You are very familiar with addition and subtraction. Subtraction will undo addition. Multiplication and division are inverse operations. Exponents and roots are also inverse operations. Roots are the inverse of exponents, and exponents are the inverse of roots. They will cancel each other out. So first of all, let's talk about what this notation is. This is read as 2 to the 4th. The 2 down here, this is called the base. And the 4 is called the exponent. So this is pretty clearly of the two, exponents and roots. This is the exponents part. 2 to the 4th means I'm going to take 2 and multiply it by itself 4 times. So I'm doing 2 times 2 times 2 times 2. Well, 2 times 2 is 4. Times 2 again is 8. 8 times 2 is 16. So 2 to the 4th is 16. This notation, this is a root. And it wants to know, first of all, this is read as the 4th root of 16. The 4th root of 16. And what we're thinking through here is what number to the 4th power gives me 16? What number to the 4th power gives me 16? Well, we just said 2 to the 4th is 16. So the 4th root of 16 is 2. Notice these number sentences occur in pairs, just like the addition and subtraction ones did. 2 to the 4th equals 16 means the same thing as the 4th root of 16 equals 2. They're written differently. This one is written as an exponent. This one is written as a root. You're thinking through them kind of the same way, but backwards. Here I want to multiply 2 by itself 4 times and figure out what that gives us. Here we want to know what number times itself 4 times gives me 16. Seven squared, 7 squared, 7 to the 2nd power. If the exponent is 2, we often say that that is squared. Exponent of 3 would be cubed. 7 to the 2nd power means take 7 and multiply it by itself 2 times. So 7 times 7 which is 49. And this is read as the square root of 49. The square root of 49. So we want to know what number times itself. Notice there's nothing written here like there was with this one. That's called the index. This one has an index of 4. If there's nothing written there, it's understood to have an index of 2. So this is the same thing as thinking through what number to the second power gives me 49. We just said 7 to the second power is 49. So the square root of 49 is 7. So if you ever see a root written with no root index up there, it's understood to be a 2. What number to the second power gives us 49? So let's work through each of these one at a time. 4 squared would be 4 times 4. 4 times 4 gives us 16. 3 to the 5th. 3 to the 5th is 3 times 3, 5 times. 3 times 3 is 9. So then we have 9 times 3, which gives us 27. 27 times 3. 7 times 3 is 21. 3 times 2 is 6. Plus 2 is 8. So we have 81 times 3. 81 times 3. 3 times 1 is 3. And 3 times 8 is 24. So 243. 2 to the third would be 2 times 2 times 2. 2 times 2 is 4. Times 2 again is 8. 1 to the 70th power. I'm probably not going to write them all out. But if we multiply by 1 by itself a whole bunch of times, 1 times 1 times 1 times 1, anytime you multiply 1 times itself, you just get 1 back. So if I multiply 1 by itself 70 times, I'm just left with 1. 3 halves to the second power, we would do 3 halves times 3 halves. And when I multiply fractions, I multiply straight across. 3 times 3 is 9. And 2 times 2, which is 4. 0 to the 5th power would be 0 times itself 5 times. Remember, anytime I multiply times 0, I get 0. And 10 to the 4th power, anytime you multiply by 10, you add a 0. So 10 times 10 is 100. Times 10 is 1,000. Times 10 is 10,000. So those are all exponents. Real quick, the zero product property says any number to the 0 power is 1. Anything to the 0 power is 1. 5 to the 0 power, 1. 22 to the 0 power, 1. 9 to the 0 power, 1. So anything to the 0 power is always 1. Let's try this set. Roots. Here we have the cube root of 27. So we want to think what number times itself 3 times, what number cubed gives us 27? Well, we said on the last slide, we said, I guess 2 slides ago, we said 2 to the 3rd power. 2 times 2 times 2 is 8. So I know the number needs to be bigger than 2. So let's try 3. 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 does give me 27. So because 3 to the 3rd is 27, the cube root of 27 is 3. square root of 100. What number times itself gives me 100? Remember, if there's no index here, it is to the second power. That'd be 10. 10 times 10 is 100. The cube root of negative 8. What number cubed is negative 8? We said before 2 to the third. 2 times 2 times 2 is 8. So what about negative 2? Negative 2 times negative 2 times negative 2. Well, negative times negative is positive 4. And positive 4 times negative 2 does give me negative 8. Negative 2 is correct. The fifth root of 32. This is one we may not be real sure what to the fifth is 32. Try something. It can't be too big because we have to multiply something by itself 5 times. Well, it can't be 1 because 1 times 1, remember, is always 1. So the next one you might try is 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So it is indeed 2. That is it for today's notes. Your next activity is to do some whiteboard practice. So you will receive a whiteboard, a marker, and an eraser. I want you to pause the video and try these problems one at a time. When you think you have one, hold it up for your teacher to see. They'll let you know if you're right or if you need to go back and fix something. Once you have finished all of the problems, and you can sit tight while others are finishing up.